Welcome everyone. Today we are solving problem 7.64 from Sadiku book. The problem says determine the value of ILT, and ILT means this one. It will be 40 ohm. Okay. Determine the value of ILT and the total energy dissipated by the circuit from t equals to 0 to t equals to infinity. Here we have a voltage source which is given as 40 minus 40 ut. So as we know from singularity functions that we can write it as ut equals to what? Equals to 0 for which range 0 is less than 0 and 1 for which t is greater than 0. So for t is less than 0, we can write it as 40 minus 40 into 0, right? 40 minus 40 into 0, which will be ultimately voltage will be what? 40 minus 40 into 0 equals to 40, right? 40 equals to 40 volt voltage. For t is greater than 0, for t is greater than 0, it will be 40 minus 40 into 1 equals to 40 minus 40, which will be 0. So voltage will be what? Voltage will be 0. So we can say easily that so the source was on before a long time ago because it is 40 volt before. So the source was on before a long time ago and turned off at t equals to 0 or t is greater than 0. Okay. So the steady state will be this one. This will be what? Steady state, right? This will be steady state. As we know for steady state for RL circuit, we can replace it will be 10 Henry actually. As we know, we can replace the inductor as short circuit in steady state mode. Okay. So for t is greater than 0, for t is less than 0, it will be in steady state mode, right? We can replace this as short circuit. Now if this is short circuited, then there will be no current flowing through this 40 ohm resistance, right? There will be no current flowing through this 40 ohm resistance. So the whole current will pass through this 40 ohm and return back to this origin, right? So and the voltage source will be what? 40 minus 40 into 0 or 40 volt. So for t is less than 0, what will be the I0 minus equals to I0 equals to what? V by R. What is the value of V? 40. What is the value of R equivalent? R equivalent equals to 40 because there are no current flowing through this 40 ohm. So 40 by 40 equals to 1 ampere. Right. Now for t is less than 0. Sorry, t is greater than 0. For t is greater than 0, it will be 1 or 40. So 40 minus 40 equals to 0. So there will be I infinity equals to 0. I infinity equals to 0. Now what will be the tau? Tau will be L by RTH. Right. Now when we calculate time constant, when the whole circuit will be in steady state mode. Now the circuit will be steady state mode in t is less than 0. So for t is less than 0, we can see easily that 40 and 40 are in parallel, right? So their equivalent will be what? 20. So L, what is the value of L? The value of L equals to 10, or inductance value equals to 10 Henry. 10 divided by RTH. RTH equals to what? 40 and 40 are in what? Parallel. So it will be 20. So 10 by 20 equals to half. Now the equation will be IT equals to I infinity plus I0 minus I infinity e to the power minus t by tau. Okay. So what is the value of I infinity? I infinity value equals to 0. So it will be 0. It will be 0. So what is the value of I0? I0 equals to 1 ampere. So 1 e to the power minus t by tau, or 1 e to the power minus 2t. So this will be the answer for problem number 7.64. Now let's start problem number 7.65. The problem says if the input pulse is applied to the circuit, determine the response IT. For this we can easily calculate the voltage, and for this here we have a voltage source Vs and the circuit, right? Okay. Now let's just break this. Let's just break this input signal, as we know how to break unit step functions, right? For unit step functions, it will be for 0, and we calculate always the amplitude for unit step functions, right? We can use as this or this, right? But I like to prefer the amplitudes. For this, the voltage will cross, it will be 10 actually. For this, the voltage will be amplitude will be high, and for this amplitude will be low, right? And for this is 10, so this will be 10 ut. For this amplitude will be 10 ut, and because this is decreasing, the amplitude will be 10 u, because it's 1, 10 u t minus 1. It was t u minus 0. So the current amplitude will be what? 10 ut plus minus 10 u t minus 1. So the equivalent will be minus 10 u t minus 1. The amplitude will be this, 10 ut minus 10 u t minus 1. So what does that mean? It does mean that 10 volt is turned on. 10 volt is turned on at t equals to 0. 10 volt is turned on at t equals to 0, right? 10 volt is turned on at t equals to 0, and a minus 10 volt source is turned on later at t equals to 0, sorry, t equals to 1. Minus 10 volt turned on later at t equals to 1, right? So the equivalent will be what? 0. So we will get back into this after a while. But we have solved this question earlier also. For t is less than 0, the voltage will be 0, right? For t is less than 0, the voltage will be 0, so Vs will be 0. So if the Vs is equals to 0, then there will be no current flowing through this current. Vs equals to 0, so there will be no current flowing through this inductor. So Is will be 0. I0 will be 0. Okay, I0 will be 0. For 0 to t to 1. For 0 to t to 1, for this range, the whole circuit will be in steady state mode. And the voltage will be what? Voltage will be 10 ampere, right? Sorry, 10 volt. The voltage will be 10 volt. Whole circuit in steady state mode. And the voltage will be 10 volt. Now, we can, for steady state mode, we replace the inductor as what? For inductor as short circuit. So if we short circuit this, there will be no current flowing through this 20 ohm, right? The whole current flow through this 5 ohm resistance and came back to its origin. So there will be no current flowing through this 20 ohm resistance. So the whole current will be flowing through this 5 ohm resistance. So here I infinity will be what? I infinity will be 10 divided by 5 or V by R. So the I infinity will be what? 2 ampere. Now let's just calculate tau. What is the value of tau? Tau equals to L by RTH. So what is the value of L? L equals to 2. What is the value of RTH? For this two terminals, what is the equivalent? 5 and 20 are in parallel, so their equivalent will be what? 4. So it will be half. Now what will be the IT? IT will be, because I naught equals to 0, so it will be 2 minus 2 e to the power minus t by tau. What is the value of tau? It will be minus half, so it will be 2 minus 2 e to the power minus 2t. This is the value of IT for this range, 0 to t to 1. Now for t is greater than 0, for t is greater than 1 actually, not 0. For t is greater than 1, what is the value of initial current? It will be I1, right? We have discussed this earlier. The value will be I1, so it will be 2 minus 2 e to the power minus 2 into 1. So what is the value? 2 e to the power 2 minus 2 e to the power minus 2. So it will be 1.729 ampere, right? I1 will be 1.729 ampere, and it will be the initial current for the function. T is greater than 1. For the range t is greater than 1. Now let's calculate IT. What will be the value of IT? IT equals to I infinity plus I1 minus I infinity e to the power minus t minus 1. Now because the tau is changing, we don't need to write this out, or we need to write this out. Okay. Now let's solve this out. What is the value of I infinity? I infinity value will be 2. So it will be 2. Here I infinity will be 0. I infinity will be 0. Here I infinity will be 0 because for t is greater than 1 range, there will be no voltage source flowing through this current. So if there is no voltage flowing through this whole circuit, there will be no current flowing through this inductor, right? So I infinity will be 0. Now if I infinity equals to 0, so IT will be what? IT will be I0. So value of the I1 will be the exact value, so it will be 1.729 e to the power minus t minus 1 divided by tau. What is the value of tau? So it will be 1 by half, so it will be 1.729 e to the power minus 2 into t minus 1 ampere. This is the answer of the problem number 7.65. I hope you guys enjoyed the video. Thank you.